Let us write an algorithm to test if a given number is prime or not prime. To test if a given number is prime or not. So for this purpose we want to develop the logic. So the first thing is, what is a prime number? What is a prime number? That's what first we should know. A prime number is a number that is not divisible by any other number except by 1 and itself. What is a prime number? A prime number is a number that is not divisible by any other number except by 1 and itself. For example, you take any number, maybe it is 5, maybe 10, any number you take, that number is definitely divisible by 1 and itself. Suppose you take 5, 5 is divisible by 5, 5 is divisible by 1 and 5 is divisible by 5. Similarly, take 10, 10 is divisible by 1 and 10 is divisible by 10. So every number is divisible by 1 and itself. So these two we have to exclude. And other numbers should not divide that number. So that is called prime number. For example, you take 2. 2 is a prime number because there are no prime number series will start from 2, of course. And you want to test this 2, 1 and itself. Of course, 1 divides 2 and 2 divides 2, but other numbers are not there. So 3 is a prime number. So 3 is not divisible by other numbers. Similarly, 5 is a prime number, 7 is a prime number, 11 is a prime number, 13 is a prime number. Like this it goes on. The prime number series will go on. So what is the logic to understand whether it is prime or not? For example, let me take number 5. What we have to do is, I am first dividing this number 5 with 1. Of course, 1 divides any number. So we should not take this 1 into consideration. Similarly, if I divide this 5 with 5, so any number will divide itself without a reminder. It will divide. 5 divides 5, so no problem. So that 5 also I should not take into consideration. Now between 1 and 5, what are the other numbers I am having? I am having 2, I am having 3, I am having 4. These are the numbers we are having between 1 and 5. Now this number 2 should not divide 5. That means when I divide 5 by 2, there is some remainder. Like 2 2s are 4, 1 is a remainder. So remainder is there means it is not divisible. So 2 is not dividing 5. Similarly, 3 should not divide 5. Yeah, 3 cannot divide 5. 4 also is not dividing 5. So divisibility means what? Remainder must be 0. But here, if you divide 5 by 2 or 3 or 4, you are getting remainder. So I can say from 2 to 4, the other numbers are not dividing 5. So this is the reason I can say 5 is a prime number. So suppose I am showing 5 by n. So suppose let me take this 5 as n. Now if n is not divisible by any number from 2 to this 4 means what? N minus 1. So if n is not divisible by any number from 2 to n minus 1, then it is prime number. So this is the logic I am going to implement now in our algorithm. So the first step of the algorithm is a start. In the second step, I want to accept the number n from the keyboard. That n may be 3, that n may be 5, that n may be 10. Then in the next step, I am taking one variable. The variable name I am taking as a flag. This flag I am taking as a true. So what does it mean? Flag is equal to true means what? This flag variable is true means I am taking this n as a prime number. When n is not prime, I will take flag as false. So when this flag variable will become false? When n is not prime. When this flag will be true? When it is n is prime, then flag will be true. So to represent that true or false, I am taking a variable by the name flag. So flag represents or indicates something. Instead of taking this name flag, you can use any other name like X, Y, Z, any other name, no problem. Now in the fourth step, what we are supposed to do, this number n should not be divisible by any other number from 2 to n minus 1. So let me take a for loop. For I values are changing from 2 to n minus 1, do, that means execute. So the number n, please remember, if I am checking, if I am testing n, suppose n is 5, I should check from 2 to 4 only. Why? Because 5 anyhow divides 5, n divides n. So I should not take into consideration that n. I should stop at n minus 1. So from 2 to n minus 1, do. Do means execute. If n is divisible by 2, that means if n% is not 2, if n% I, that means I value may be 2, 3, 4, up to n minus 1 I have to check. So if n is divisible by I, that means if n% I is equal to 0, means what? Remainder is 0. That means n is divisible by I. Then what I can say? Then I can say that n is not prime. That means into flag I can store, false. So once n is not divisible by I, only once n is not divisible by I, that is enough. It is not prime. You need not check other numbers. So you can break the loop. So break means come out of the for loop. Now in the next step I can say if flag is equal to true, then print it is a prime number only. Else means what? Else means what? The flag became false. When a flag will become false? When it is not a prime number. So else print not prime. Then in the sixth step we should stop. So this is the logic to decide prime number or not. Now let us convert this logic into a Python program. To test prime or not. So this is my comment line. The second line in the logic is input n. That means you have to take the number from the keyboard. So enter number. So I can ask the user to enter a number, and that number input function will take that number entered by you as a string. So this int function will convert that string into integer and then it returns that integer into n. Now the next step is take a flag as true. So you can use true in Python. Then the next step is for I in range. Please observe, I have to change I values from 2 to n minus 1. So range function, in range function I have to write 2 comma n. When I write 2 comma n, range function will generate numbers from 2 to n minus 1 only. So n it will not generate, up to n minus 1 only it will generate. So I values are changing from 2 to n minus 1 colon, and then if n%i, that means n is divisible by I, then the remainder will be 0. This percent operator is also known as modulus operator. It will give the remainder of division. If that remainder is 0, that means n is divisible by I. So if n is divisible by I, then it is not a prime number. Then into flag I want to store false because it is not a prime number. Then I want to break this loop. When n is not a prime number, you need not continue the for loop checking with other numbers. So you can break the loop. Break statement in Python is useful to terminate a loop. It may be for loop or it may be while loop. You will come out of that loop. Now if flag is equal to true, what does it mean? Still the flag value is true. That means it is not false. It is true. That means none of the I values have divided this n. That means flag is equal to true means n is not divisible by I. So that means it is a prime number. So print that n is prime. Else means what? Flag value is false. That means flag value is not true. That means when flag value will be false, at least one I value, at least one number in this range 2 to n minus 1, at least one number divided this n, then the remainder will be 0, then flag will be false. One number divided that n means it is not prime. So print n is not prime. So this is the way you have to decide prime or not. File save and then run module. So it will ask you enter a number. I am entering 5. 5 is prime. Let me test once again. Run module. Enter number. I am giving a 10. 10 is not prime.